Lesson 5.1, Random Variables. Example 1. A family has 3 children. If the genders of these children are listed in the order they are born, there are 8 possible outcomes. BBB, BBG, BGB, BGG, GGB, GBG, GBB, and GGG. Assume these outcomes are equally likely. Let X represent the number of children that are girls. Find the probability distribution of X. Okay, so if X stands for the number of girls, then our options are there can be no girls in the family, there can be 1 girl in the family, there can be 2 girls in the family, or there could be 3 girls in the family. And then the probability of X well, the probability that you don't have any girls, we'll have to look back up here at the sample space. And we notice that there's only one that has no girls in it at all. And that's this one right here, the BBB. So the probability of a family with no girls is 1 out of 8. Alright, now we come back up here again. We're looking for the probability of having 1 girl. Well, let's see. There's 1 girl. There's 1 girl. That one has 2. That one has 2. That one has 2. There's 1 girl. That one has 3. So the probability of a family having just 1 girl is 3 out of 8. Alright. And then we want to know the probability of a family having 2 girls. So let's see. There's 2 girls. There's 2 girls. There's 2 girls. That's just 1. That's 3. This has 1. This has 1. Alright, so the probability of having 2 girls is going to be 3 out of 8. And then our last one, the probability of having all 3 girls, well, if we look back up here, it looks like the only opportunity to have 3 girls is right here, and there's only 1 of those, so the probability of having 3 girls is going to be 1 out of 8. And so there is our probability distribution for X. Example 2. True or false? The table shows the probability distribution for the number of boys in a family of 4 children. Why or why not is this possible? Okay, there are 2 conditions to be a probability distribution. The first condition is that the probabilities all have to be between 0 and 1. And if we take a look at this row down here, this probability fits that. It's less than 1, bigger than 0. In fact, they're all going to be less than 1 and bigger than 0. So that fits. The second thing we have to do is we have to add up all these probabilities and make sure that they're equal to 1, because if this is a true probability distribution, all of these probabilities are going to add up to 1. It turns out, though, that when we put these in the calculator, we actually get 1.37. And for that reason right there, this is not a probability distribution. And the reason is because the probabilities add up to more than 1. Example 3. Which of the following tables represents a probability distribution? Okay, remember the circumstances that have to happen in order for us to have a probability distribution. All the probabilities have to be between 0 and 1, and all the probabilities have to sum to be exactly 1. Not a little over 1, not a little under 1, but exactly 1. Alright, so in A, all of our probabilities here, they are bigger than 0 and they're smaller than 1, so that's okay. Alright, let's add these together here. 5 and 5 is 10, and then 5, 6, 7, 8, 9, 10, and then you carry the 1 over here. This adds up to 1, so this is a probability distribution because the probabilities add up to 1. Alright, let's check B. Alright, this is between 0 and 1, so it's this one, this one. Looks like all of these probabilities are between 0 and 1. So So let's add the probabilities together and see. 7 and 5 is 12. This is 13, 17, and 5 makes 22. We'll carry the 2. 2 and 2 is 4. 5, 6, 9, 10, 11. Carry 1. And so this probability adds up to more than 1. This is not a probability distribution. And then over here for C, alright, this probability is between 0 and 1. This one's good. This one's good. This one's good. Let's add those probabilities together. 2 plus 1 is 3. 3 plus 3 is 6. And then 4 more gives us 10. Alright, 1 plus 0 is 1. Plus 4 is 5. Plus 2 is 7. Plus 3 is 10. Carry the 1. 1 plus 0 plus 0 is 1. This one is a probability distribution. Example 4. The following probability distribution of a random variable represents the number of extracurricular activities a college freshman participates in. A. Find the probability that a student participates in exactly 2 activities. Okay, so we are looking for the probability of 2 activities. And that is right here. When x is equal to 2, the probability is 0.45. Alright, B. Find the probability that a student participates in more than 2 activities. Alright, so that means in our case, either 3 or 4. So if x is equal to 3, here's the probability. If x is equal to 4, here's the probability. Alright, so the probability of 3 or 4 activities is going to be 0.21 plus 0.14, and this is going to give us 0.35. Alright, C. Find the probability that a student participates in at least 1 activity. Now, at least 1 means they participate in 1, or 2, or 3, or 4 in this case. Now, there's 2 ways to work this problem. One way is to come up here into our chart and add together the probability of 1 activity plus the probability of 2 activities plus the probability of 3 activities plus the probability of 4 activities. Or we can use the complement, okay, which means that we would find the probability that the student participates in no activities, and then we could subtract that from 1. Okay, so the probability of at least 1 is the same thing as 1 minus the probability of none. And this is the property that I'm going to use. Alright, so the probability that a student participates in no activities is right here, 0.06. And that's going to give me 0.94. Example 5. There are 5,000 undergraduates registered at a certain college. Of them, 478 are taking 1 course, 645 are taking 2 courses, 568 are taking 3 courses, 1,864 are taking 4 courses, 1,357 are taking 5 courses, and 88 are taking 6 courses. Let x be the number of courses taken by a student randomly sampled from this population. Find the probability distribution of x. To do this problem, I think it might be a little bit easier to make our probability distribution in Excel. And so I'm going to pull up my Excel sheet right here. Alright, x is going to stand for the number of courses that a student has taken. And that's going to be 1, 2, 3, 4, 5, 6. And then down here, this is going to be the probability that a student is taking one course. Well, if there are 478 students who are taking the class out of 5,000 students on campus, and that gives us the percentage of 0.0956. Alright, now we got 645 out of 5,000 students. Oops. I'm going to put my equals in here. Alright, and then we have 568 out of 5,000. And then we have 1,864 out of 5,000. And then we have 1,357 out of 5,000. And I forgot to put my equals in there again. And then finally, taking 6 classes, we have 88 out of the 5,000. There we go. And there is our probability distribution. Example 6. The probability histogram shows the number of children a woman has. The numbers on the tops of the rectangle are the heights. A. What is the probability that a randomly chosen woman has exactly 2 children? Well, if we go to the top of the histogram, and that's going to give us at the top of the 2 right here. So the probability that a woman has exactly 2 children is going to be 0.244. Alright. B. What is the probability that a randomly chosen woman has fewer than 2 children? Well, that's going to be this rectangle here. This is 0, and 0 is less than 2. And this rectangle here, which is 1, also less than 2. So the probability of having less than 2 children is going to be 0.273 plus 0.160. And this is going to give us 0.433. Alright, and then C, what is the probability that a randomly chosen woman has either 4 or 5 children? Okay, so here's the 4 numbers, 0.082, and 5, 0.039, and the probability of either 4 or 5 children, 0.082 plus 0.039, and this gives us 0.121. Example 7. A true-false quiz with 10 questions was given to a statistics class. Following is the probability distribution for score of a randomly chosen student. Find the mean score and interpret the results. Alright, according to our formula, what we want to do is we want to take each one of our scores in this case and multiply it by the probability that a student will get that score. Alright, so our mean for our probability distribution x will be 5 times its probability of 0.04 plus 6 times its probability of 0.16 plus 7 times its probability of 0.36 plus 8 times its probability of 0.24 plus 9 times its probability of 0.12 plus 10 times its probability of 0.08. And when we put this in the calculator to get our grand total, we will get 7.48. Alright, now our interpretation is going to be, as more and more students take this quiz, you would expect the mean to approach 7.48. Example 8. The following probability distribution represents the age of a student at a certain public high school. A. Find the variance of the ages, and B. Find the standard deviation of the ages. Okay, now I'm going to pull up an Excel spreadsheet so we can do our work over here. Alright, so here is my probability distribution, and the first thing I want to do is figure out what the mean is. Okay, alright, so we're going to put in our formula here. Alright, and we are going to multiply C2 times C3, and then we're going to add that to D2 times D3. Oops. And then we're going to add that to E2 times E3. And then we're going to add that to F2 times F3. And then we're going to add that to G2 times G3. And then we're going to add that to H2 times H3. And that will give us the mean of 15.25. Alright, so now that I have the mean, I need to come in here in this column. This is my x minus the mean. And so what I'm going to do is I'm going to take B7. Actually, I should probably do an equals sum on this. Equals sum B7 and I'm also going to add it, or add to it, C16. I want to have a negative C16 though. So let's do negative 1 times that. Okay. Alright, so what I've just done is 13 minus 15.25, and that gave me this one right here. Okay, now I'm going to go back in this formula and I'm going to put that $sign in here to hold that C16 in place, and then I'm going to take this and I'm going to grab the corner of it and I'm going to bring it down, and there are all of my x's minus my mean down here, 14 minus 15.25, 15 minus 15, and so on and so on and so on. Alright, the next thing I want to do is I'm going to come over here in this D column, and I'm going to square everything back here from the C column. Okay, so we're looking at equals, I'm going to take cell C7, and I am going to raise it to the second power, and that's going to give me 5.0625, and then I'm going to grab the corner here to copy this formula on all the rest of them, and now I have all of the squares of this column over here. Alright, The next thing I'm supposed to do is I'm supposed to take this column here and multiply it by that column, and I'll put my answer over here on this side. Alright, so this is going to be equals, and I am going to take D7, and I am going to multiply it by E7, and that gives me 0.405. And again, I'm going to grab this corner here, and I'm going to drag that down, and this has given me the sum of all of the squares of my x minus means times my p of x's. Alright, and so finally down here, to get to the variance, I'm just supposed to add this column together. So we're going to equals sum, and we are adding, this is F7, and we are adding all the way down to F12. And there we go. That gives me my variance of 1.6075. Okay, and so my variance right here, and the next thing I'm going to do is I'm going to figure out what the standard deviation is. I'm going to put that one right here. So in this cell, remember the standard deviation is just the square root of the variance. And so we're going to SQRT, this is square rooting, and I'm going to square root that cell, which is F13. And that is going to give me the 1.2678, blah, 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 blah. And I think I'm going to shorten that up just a little bit because we have been rounding everything to 3 decimal places, and so, or actually these have all been rounded to 4 decimal places, so we'll keep that. So that gives me the 1.2679 for my standard deviation.